We're going to call the meeting to order now. Welcome to our meeting, Columbus Astronomical Society. It's going to be an interesting night. So I guess we'll start off with our host, who's been hard-pressed lately with building issues.
All right. Thank you. I'm Don Stevens. I'm the director of Perkins Observatory. I want to start off by thanking folks that came out and helped with our program up at Ohio Wesleyan last night. It turned out to be a beautiful night and had a lot of telescopes set up and put a lot of people by those telescopes, and went very well. You guys did a good job. Everyone had compliments as they were leaving about you guys, and appreciate it very, very much. You made that a successful event, and I'm sure the administration, I haven't heard yet, but I'm sure they'll be pleased with the way the outcome was as well. We're still on a hiatus at programs here. Still got a lot of work that needs to be done in the building and such. So just let folks know, if you haven't noticed already, we're limited to a single-use restroom around the corner over here in the hallway. So do bear that in mind. I'm not sure when exactly we'll get back to normal operations yet. I'm hoping here in the next month or so, but we'll see.
Thank you for the white light bulb in there.
No problem.
I can see where you're at.
Of course. Just I'll keep folks posted on that, and I appreciate your patience and such in that regard as we get through these issues with building. It's a 100-year-old building, so it needs a little TLC, and we're getting there. I'm hoping to get some estimates on some improvements and work and things like that. And so if you want to help us out with that on the cost, we're a nonprofit. You make a donation, it's tax deductible. You can do it online. Wesleyan has a donation website, and you just select Perkins Observatory from the drop-down menu there. They take credit card, of course, and things like that. So if you want to flow us a few bucks, every dollar counts, every dollar helps. So I appreciate that very much. Once we resume programs as well, I'll make an announcement about that, and always happy to have volunteers come and help with those programs. If you have an opportunity on the Friday nights, and then hopefully we'll also have the Celebration of the Sun programs in July as well. Those are on Saturday afternoons, and we do some solar observing with our solar telescopes and do rocket launch for the kids and stuff like that. It's usually a fun time as well. So, but thanks a lot for those that support us, and I hope you'll continue to do so down the road. Thanks a lot.
Okay, so, report.
We have one guest today, and that is Johannes. Stay right there. Welcome to Johannes. And you just so happens that you're sitting right in front of our treasurer. So if you do want to write him a check for $25, you can become a member tonight. He said he was interested, Alec. So welcome. Also have a couple of outreach events that we need some help with. And if you are willing to help out with either the High Banks event on July 12th, the times are different. I changed them to 8:30 to 10:30. It said a different time on there before, but we found out that we could do it later, seeing as the sun doesn't set till 9 o'clock. But June 12th and July 25th. The 12th is at High Banks. The 25th is at Delaware Deer Haven Park, which is not too far from here. So I'll pass these around. If you are willing to help us out, please sign up. Make sure you give us your name, email, and phone number so we can contact you to remind you. Okay?
Okay, thank you. So, we'll hear from CAS, our viewing SIG.
Yep, thank you. So, good evening, everyone. My name is Isaac Cruz, and I'm the lead for the CAS, which is the Columbus Astronomical Society Imaging, SIG, Special Interest Group. And, if you're interested on really what it takes to take images of the sky and, kind of like process them and, basically have in your home some of those beautiful pictures that, sometimes you see around and so forth. Well, we have a SIG, a special interest group that is just for that. We actually meet here on the third Saturday of the month at 1 p.m. But as Don said, the building is kind of a little bit compromised. So the plan that we had was for next week. We were going to have a PICS Insight workshop, which is very high intensity. 3 days, like Friday, Saturday, and Sunday, a total of, like more than 12 hours of instruction to actually get you to the point where you can actually use the software to process your astronomical data. So that was the plan, but given that we actually have, these issues, I'm going to kind of delay that. It's not going to be in July. It's not going to be in June. We'll see if we can actually make it July or a little bit later during the, during the year. So we'll put a big TBD at this point. So that means that this next upcoming Saturday, I wanted to at least have a CASIS meeting. So the theme of the CASIS meeting next Saturday is going to be how to use NINA. NINA is a software that is used for image acquisition. So it's an image acquisition software. It's free and it's very popular. And I wanted to introduce that, to anybody that was interested on actually learning how to use that software to, acquire data, for take pictures of the of what's up there. So again, you're all invited. 1 o'clock here in this venue, and next Saturday. Hope to see you all there. If you're interested, it'll be great to see you. Thank you very much.
Okay. So, Alex. Yeah.
All right. Good evening, everybody. Let me get my thoughts straight here. So, a few folks have talked with me in the past about the annual Hidden Hollow Star Party over in Mansfield. Just want to let everybody know that normally I have a very loud voice, so microphones are a unique thing for me. All right, well, anyway, for those online, the Richland Astronomy Society is going to be hosting their annual Hidden Hollow Star Party on September 19th through 20th this year. Usually that Friday night they'll do some sort of, usually one presentation or so, and then if the skies are clear, they'll do observing and astrophotography out by the telescopes. And then on Saturday, there's usually several presentations, followed by just a lot more observing, assuming the weather's clear. Which usually September in Ohio is pretty good for observing. But if you've never had the opportunity to go up that way before to see their star party, it's about an hour away from here, and it's definitely worth the trip in my opinion. I'm a member of both clubs, and I see a lot of Franklin County license plates when I go to their meetings, and they're not people who are also members of this club. So it could also be a good opportunity for us to maybe find some additional folks to join us here is another local club in Ohio. So if you have any questions on that, talk to me afterwards, but it'd be great to see a great CAS contingent there this year.
What's the date again?
September 19th and 20th. Yeah, I hope that's a Friday and Saturday.
Okay. You're up next.
I'm up?
Yeah.
How's it going, gang? We're still doing programs down at the John Glenn Astronomy Park. I just wanted to update you guys on the concert that we were working on, and it has been scheduled. The dates are August 16th is the primary date, and then the rain date, that's a Saturday, by the way. The rain date will be the following Saturday on August 23rd. That's third quarter moon, very close to new moon, so it'll be a dark sky anyway. At sundown, roughly, the Hocking Hills Community Orchestra will be doing a concert, and then I'll be doing like little talks in between, talking about what they're talking about. We're going to attempt to do astronomically themed classical music, which I believe is going to be Holst, and maybe a few other things. So that's the concert. If that's interesting to you, you're welcome to go down there for free and join the crowd. The orchestra is going to be in the plaza, and we're going to be sitting out in the field. There is no charge for it, but we will strongly encourage you to put a few dollars in the box, because it is in fact a fundraiser. We're not allowed to charge money for this sort of thing, but we can actively encourage you to simply drop something in our box. So that's it. That's all I've got. So.
Okay, so now that the rainy season has let up a little bit, I encourage everybody to get their scopes out, even if it's just in your backyard, and go for whatever easy things you can find in the city or near the city, wherever you live. But take advantage of the opportunity to practice with your telescope, getting it set up and, finding targets. That's sort of the key to it. Get you a good star chart so you can find things. So now we've got our tech wizard who's going to do our presentation here, talking about smart scopes.
Yeah. Thank you. We're of the Columbus Astronomical Society for about 25 years now. And I've done a bunch of different things. I've built telescopes, I've polished my own mirrors, I've done astrophotography since 2005. I've done just about everything. I'm a visual observer. I've used various types of computerized telescopes. But this past year has been a pretty eventful year for me, especially in regards to smart telescopes. So, since my last talk, was that last year, I believe, I sold my Dwarf 2 to a friend of mine, and I purchased the SeeStar S30. It's the same kind, and I'll talk a little bit more about it later. It's a smaller aperture, but it gives you wider field of view. It's pretty cool. I have a new website out. It's called xray-echo.com. That's where it's mostly for all my hobbies. Many of you probably know that my hobby is collecting hobbies. But if I could only choose one, it would be amateur astronomy. But it's mostly geared towards amateur astronomy, where I'm going to put articles and stuff up there about it. I started a clinic on Zoom calls. It's the PIX Insight Processing Clinic for SeeStars. And I also published an online tutorial of how to get started with SeeStars. And I believe the Prime Focus is now going to be running those articles as well. Pretty cool. Some of you know I'm an amateur radio operator. That's one of my hobbies. I run an astronomy net on amateur. Think of it as an interactive broadcast. I've been doing this for 6 years, so we celebrated 6 years in January, so that's been cool. And we have a contingent of SmartScope users in this amateur radio group, which is kind of exciting. So I tell people, if you want to check into this net, be prepared to spend some money, because usually everybody ends up buying something. I began my Messier SeeStar project, where my goal is to get all of the Messier objects with a SeeStar. I'm about halfway there. The other thing I did was I went ahead and upgraded my main imaging rig to be more like a SeeStar. And ZWO, who makes the SeeStar, they have something called an ASI Air. And if you have ZWO hardware, it can all interact with the ASI Air and make it more like a SeeStar, where you can run it from your smartphone. It's pretty cool. Also, we had our lunar eclipse. So I did a lunar eclipse session, stayed up all night, took the day off. Using RGB data with the SeeStar, and combining that with my data from the big rig. And I'm just starting to do science with it, right? Okay, and that's the presentation. Thank you all for coming. Just kidding. All right, so let's talk about the SeeStar S30. This is a really cool little device. My wife and I are going down to North Carolina to the beach down there. I'm taking the S30 with me because it's pretty darn small. If you look how big this thing is, that's it, right? And here's the carrying case. I mean, that could fit into a backpack, right? It has a wider field of view. It uses a 30 millimeter aperture, whereas the S50, which came out first, is 50 millimeters. It's 250 millimeter focal length on the S50, 150, I believe, on the S30. I think I have it on there somewhere. There it is, yeah, I was right. The cool thing about it, because you have a wider field of view, you can take longer exposures in alt-azimuth mode, which is really nice because alt-azimuth has a function, or not a function, but a thing where you have field rotation. As an object is going across the sky like this, and you're in alt-az mode, it's going to rotate, right? So you can do longer exposures in alt-az mode. It's got the new Sony chip, which has the Starvis 2, which means it's more sensitive to lower light. Just like the Dwarf 2, it has two lenses. It has a wide field lens, so you can do landscape shots and things like that. And then, of course, the main objective. Smaller and lighter and very portable. It's a pretty neat little device. My new website, xray-echo.com. This is where I'm going to start posting articles about astronomy, and if you're into ham radio and model trains, you can read those too. But so far, most of my articles have been about astronomy, where I do tutorials, reviews, and just general rambling musings of an idiot like me. Here's the processing clinic that I started for SeeStar imagers. I do Zoom calls with this. And so what this started me on is creating the series of articles on my website so other people can learn more about it. Mentioned my digital voice net. We celebrated 6 years this year, so if you're a ham radio operator and you have digital radio, you can check in on Wednesday evenings at 9 p.m. Eastern time. And we have people all over the world. We have someone from South Africa that checks in, someone from, a couple people from Australia, and of course all over the United States and Canada. It's a pretty fun time. So here's my SeeStar Messier project. As you can see, I'm getting close. This is my grid of stuff. All my images are published up on a really great site called Astrobin. Man, I wish we had this back when we first started imaging. You know, it's pretty cool. Back then, we had to manually publish our images on our own website. This does everything. It even does like plate solving and puts all the interesting diagrams on top of your photo to show what everything is. So here's the big rig. Well, it's one rig, but two different telescopes. So you'll see here, this is something called the ASI Air, which is really a fancy Raspberry Pi with a bunch of connections. And I've added a new camera, the ASI 1600mm, which gives me a wider field of view, electronic focuser, and then I just got this thing right here, which is the CAA. That allows me to automatically adjust the rotation of the camera. So say that I took a picture last year in this particular orientation with this particular telescope, it's smart enough to know that the next time I want to image it, it'll automatically rotate the camera to that orientation. Another great thing is my goal this fall with the wide field telescope is to get the Andromeda Galaxy. And I can rotate it because the Andromeda Galaxy, if you look at it from an equatorial perspective, it's kind of tilted. Well, now I can actually rotate the camera so that it all aligns on the chip. So that's been a really fun addition to the telescope. So I'm not getting rid of my big rig, but I'm not setting it up every time I want to go image. I'll get the SeeStars out. But when it's new moon and that rare configuration of clear skies and a new moon, I'm going out with the big rig. But the SeeStars are coming with me. Lunar eclipse. Anybody see the lunar eclipse? We were blessed with clear skies. We had a solar eclipse and a lunar eclipse in Ohio, and it was clear. I did not want to miss that. So this was like the first night that I got everything out on the back deck, the big rig and both SeeStars. This was what I was doing. I was watching Star Trek Voyager, staying up all night. I was talking on the radio with one of my friends in Michigan that's on the astronomy net on ham radio, and him and I are talking the entire night doing this. So this is the S50, and just because I'm weird, the smaller telescope, I use an Android phone, because it's smaller, right? You know. And then the other Android tablet is the ASI Air. So that night I was taking pictures of the Orion Nebula in narrowband, which is great because you can do that during full moon. And I was doing it during the eclipse, which was kind of cool. So here is what the SeeStars did that night. I did a time lapse. So the one here on the left, that's the S30, and the one on the right is the S50. So it gives you an idea of what the field of view for both smart telescopes are, right? You can see the wider field of view. Now, one of the things that's annoying about these smart telescopes, the chip is oriented up and down.
Which one's the SeeStar, which one's the S30?
Well, they're both SeeStars. This one's the S30. Yeah, and this is the S50. Yeah. You'll notice that it's oriented up and down. And I'm like, why would they do that? And then someone told me, said, because you're using a smartphone. And then I went, oh, it's annoying. So, but you can get around it. So anyways, that's an example of that. And here's what, I was really proud of this. This is my image. That doesn't look great on the screen just because of the way it is, but this is my narrowband image of M42 and M43 during the lunar eclipse with the big rig, with the new SeeStar configuration on it, or the ASI Air. So I was pretty proud of this. It was pretty neat. I was doing this from my backyard. So I mentioned earlier, I'm starting to take, and PixInsight does a great job of allowing you to do this, I'm starting to take the RGB data from the SeeStar and combining luminance data. And what luminance data is, that's your black and white, all wavelengths coming into the camera. And that's where you get all of your details. And luminance you can do in just black and white, just regular light, or you can do it in certain narrowband filters like hydrogen alpha. So what I did is I took the hydrogen alpha from the Cone Nebula and the color data from the RGB data, or from the SeeStar, and made the Cone Nebula right there. So you can see there's a lot of detail there, and that's from the hydrogen alpha luminance data. I combined it with the RGB data from the SeeStar. Here's an example of using regular luminance data and RGB data of the Leo triplet. So I'm starting to experiment with combining the SeeStar, which is very good at getting all of the light from the colors. Yes?
Can we dim some lights out
Oh.
so you can see better?
Sure.
Right behind you.
Right behind you. There.
Oh, no, not that one. That one. There.
There. Well, here. I'm going to start over. Nah, just kidding. Yeah, so it looks a little better. So you can see some details here. This is RGB. No SeeStar was harmed in the getting of this picture, right, or the obtaining of this picture. This is all from the big rig. But it's different because I was using the ASI Air to control it. And then here, there's all that detail. I mean, you can look at just the detail in the cone was really interesting. And I took this like 4 or 5 years ago with a hydrogen alpha filter. And then I took the Cone Nebula this past around Christmas time, combined them together into this combined shot. And then recently I did the Leo triplet using the big rig for the luminance and the SeeStar S50 for the RGB. Actually, I take that back. I was using the S30 for that one. So this is the thing I've been really wanting to do for a long time with the SeeStar, with smart telescopes. And I honestly think this will allow people to start contributing to science in a big way, because it's low cost. The SeeStar was $349 when I bought it. I think it's $399 now. Unfortunately, they come from China. So you're looking at, right now, under $500, you could start doing some cool science. And this is one of the first things I started doing. SeeStar photometry. I was able to estimate, I still need to work some things out. As you can see, this is kind of what everybody else is coming up with, and there's mine all out there by itself. I'm like, I don't think that's right, it's an outlier. But I'm getting better at it. And I use some software, it's called Tycho Tracker, which is used for astrometry. But I started learning how to do variable star estimates using the SeeStar. Here instead of me setting up this big telescope, getting variable star estimates, now I can set up this small telescope, watch Star Trek Voyager, while I'm bopping around the sky getting variable star estimates. So here's the next big thing, this is what I've been really diving into. I've been reading a lot of astrophysics books about this, and that's spectroscopy. I think spectroscopy to me is as big as when we started using telescopes to look at the stars. Spectroscopy is when we started to learn that the stars are made up of the same stuff as what we find on Earth. Spectroscopy allows you to see the various elements and chemical signatures inside of stars. So using a very cheap, and I brought them here, or here it is, and you guys can see it. In fact, if you want, we can pass them around. Please don't press on this. You know how kids like to press on the shiny part of a speaker, and they just poke it in there? Don't do that, please. So that's the S30 spectroscopy thing. And then here's the S50. Now, I did not 3D print these. There is an awesome amateur astronomer named Kai Young, and he runs the SmartScope Underground, or Underworld, Facebook group. And he is blazing trails with smart telescopes. So I'm not coming up with this stuff on my own. He's like, him and other people in the community are actually coming up with new ways to use the SeeStar and other smart telescopes to come up with ways to actually do some cool science. And I'm so excited about this first part. I dedicated more than one slide to it. And this to me is kind of like, I originally wanted to be an astrophysicist and study stellar evolution, but then I realized I needed to pay bills, so I went into IT instead. I don't regret that, but this is kind of like scratching that itch that never went away. So how do you do this? This thing right here is called a woven metal sheet. It's like a fabric. The dimension, I don't remember the exact dimension of it. Think of it, if you think of a metal grating, but think of it like squished down to be really small. They use it for things like filtering liquids and chemicals and particles and things like that to make sifters. But Kai found out a way that you can use it to do spectrum. Now it's low resolution spectroscopy. You're not going to get all those fine little lines that like a slit spectrometer will do. But you're getting about 15 lines per millimeter, which is enough to see some things. Especially like some of the big fingerprints of some of the stars. I'll show you an example of this. I use something called RSpec. It's made by the company that makes, some of you may have heard of the Star Analyzer 100. And it's a blazed grating that you can put in your filter wheel or in the front of the nose of your CCD camera, or with a special attachment, you can use it on your DSLR camera. And it allows you to get spectra. Well, this is the cheap way to do it. I went ahead and paid for the software because I like the interface better, but they have a free piece of software called BASS. It's made by an organization in England. Oh, and Kai's the one that 3D printed this. He doesn't give the plans out, but I plan to like make my own because I don't like the design of this. I want to come up with my own design, which I will provide to anyone here. And I bought a big sheet of this woven stuff, this metal woven sheet, so that we can all have spectrometers if we wanted to. So I want to go through some of the classes of stars that I've done some spectra from. This is with the SeeStar. One of the things when you do spectroscopy is you don't want to focus on the star. The way, I'm going to do a presentation sometime later about how you do spectroscopy in detail, but you don't want to focus on the star, you want to focus on the spectra, right? Because the way spectra works, it comes down at an angle from the primary, and it spreads the light out. Now, not all of it gets in focus, so you have to focus on the spectra and not on the star. You can see this star is slightly out of focus. That's perfect. Now, with Regulus, with a B-class star, you're going to see more light over here in the blue and the purple. You're going to see less light in the red. Now, with B-class stars, you'll start to see there's a little dip here, but it's not very prominent. It's hard to see it here, but there's a little notch right here. That's your hydrogen beta line, right? A lot of stars, except for M-class stars, have that hydrogen beta line. Now, it's not very pronounced. It's just a little notch there. And you'll see some other dips, but this is the one I was concentrating on the most. So this is a B-class star. So we're towards the more luminous side of our stellar classes. Now this one is the most exciting one that I've ever done yet. A-class stars have a very prominent hydrogen B or hydrogen beta absorption line. And you can clearly see that notch right there, see it? And it's right there at that frequency of hydrogen beta. Another thing you'll start to see are hydrogen alpha absorption lines, and you start to see them over here in the red. This is with, it probably cost $2 for that little piece. I had to buy the whole sheet, but if you divide it up, I'm getting spectra of stars. Now, I'm not going to write scientific papers with this, but for me, this is pretty exciting. When I saw that notch in the hydrogen beta area, I was like, this is working. This is how I knew it was working. In fact, when you calibrate your data, you set the 0 point to here, where the star is. Then you find that notch and you say, okay, that's hydrogen beta, and then it fills in the rest. It's not the most accurate spectra, but you start seeing the characteristics of different classes of stars. Here's Procyon. Now, with Procyon's an F-class star. You'll still see your hydrogen beta line, but you'll start to see a little bit. This wasn't the best spectra that I have ever gotten. This was the first one I ever did, so I'm not too happy about it. But you'll start to see some of the absorption lines towards the red end. But Arcturus, this one was really cool because you still see that slight blip for hydrogen beta, but with a K-class star, you start seeing the sodium absorption lines show up more prominently in this area of the spectra. You still see a dip here for the hydrogen alpha. But when I saw this, I'm like, okay, I think it's working, because I looked up Arcturus's spectra online, and it shows very similar to this, where you start seeing the absorption lines showing up in that sodium area. So I was pretty excited about it. And just so you can see, it's probably not, you could see like a little notch right here in the blue. That's that absorption line. Now, one of the things about stellar spectra that I've been learning about, and those who have more knowledge than me, hopefully I'm not way off base here. When the absorption line is wider than what you would think, that means the star is rotating faster. If you had a really good calibrated grading, and so you know exactly where the line should be, and then the hydrogen beta line is slightly off to the left or right, you could start measuring redshift. I'm not measuring redshift here. I'm not really measuring how fast a star rotates, but this can whet your appetite into this really fascinating area of astronomy or astrophysics, especially for amateur astronomers. Now the sky's the limit. You can get a slit spectrometer, and you can probably spend about $1,200 on something like that. But still, I'm pretty excited about what I've been able to do with a $25 3D printed thing and a $2 metal grating or metal woven cloth. So here's some of the improvements that have been occurring with smart telescopes from ZWO. There's a new SeeStar planning mode. There's a new mosaic mode that automatically allows you to take mosaics. This one's the biggest thing that came out. The new EQ mode. Now the Dwarf 2 and Dwarf 3 already had that out. But when the ZWO introduced it, it allows you to take better pictures in longer subframes. So like normally in alt-az mode, especially with the S50, you can get away with 10 seconds and it'll reject some of the frames. In the EQ mode, you can do 30 seconds and it hardly rejects any frames. ZWO is coming out with 60-second subframes in the near future. So Dwarf Labs, one of the one of the things that were deficient with Dwarf Labs software, it didn't have star charts. Dwarf Labs now has star atlases where you can pick and choose where you want to go in the sky. Before, you had to actually tell it what thing you wanted to go to. The Celestron Origin telescope is now shipping so far. It's almost like I got to put an asterisk on the whole presentation because we don't know if we're going to be able to get this stuff in the future. Neat thing about the Celestron Origin, and I have a really good friend of mine who owns one, it's a 6-inch RASA, which is like Celestron's it's a really good imaging telescope. Who runs the smart telescope Underworld. He came out with something called SeeStar ALP, and it runs in Linux, Mac, Windows. It can control more than one SeeStar at once, whereas I need to disconnect and connect to the next one. Or what I did is I bought multiple Kindle Fires to allow me to control more than one thing at once. With this, you can control a whole army of SeeStars. I've been communicating with him, and he was telling me pretty soon he's going to have automated photometry installed or running with SeeStar ALP. And it's free. So the planning mode. With the ASI Air, you can plan your entire night and tell it to shut down at the end. They now have added that functionality into the SeeStar. A lot of people have said that a SeeStar has a dumb ASI Air in it. It's like a mini Raspberry Pi. ZWO is slowly introducing more things into the SeeStar to make it act more like an ASI Air. One of those things is the SeeStar planning mode. It allows you to say, hey, I want to look at this object for this long at this time, this object for this long at this time. Great for if you're doing asteroid hunting or if you're doing supernova hunting, or you just say, hey, I'm tired, it's going to be clear all night, I'm going to set this thing up and let it run. The mosaic mode. So here is an example of me using the S50 in mosaic mode. And so this is a representation in, I forget what star chart, I think it was Stellarium, of the double cluster. And this was done in the mosaic mode, processed in PixInsight. Here's another example of the Andromeda Galaxy. Drank too much coffee today. So this is the SeeStar mosaic mode of the Andromeda Galaxy. It works pretty good. I have a tutorial on how to do this, how to combine the mosaic. So there's two things you could do. You could take all the raw files and stack them together inside of a software program like PixInsight or Cyril. Or you can use the SeeStar and it'll do it automatically. I like having more control and I stack this inside the software. So I wrote up a tutorial on my website, xray-echo.com. It's also in 8xe, mycallsign.com. And that's where X-ray echo comes from, November 8, X-ray echo. Get it? And it tells you how to do this in PixInsight, and if you run into problems, some of the solutions. The SeeStar EQ mode. This is really neat. It'll actually help you polar align your SeeStar. It tells you, hey, get it to this particular angle, and then it automatically goes and starts looking for stars and tells you how far off you are from the pole. And then you adjust your altitude and azimuth of your equatorial mount, and you adjust it and until it gets it just right. Now, it's not as critical as something like an ASI Air or a big rig. As long as you're within like a half a degree from the pole, it should be fine. I like to get a little closer than that. But I can get 30-second frames with both the S50 and the S30. And I'm going to show you some examples of what I've been able to accomplish. So most recently, down at John Glenn Astronomy Park, that was one of those rare confluences of clear skies and a new moon. And I'm like, I'm going to JGAP. I don't care if I got to work tomorrow. I'll push through. This is 3 hours of 30-second subframes using the S30, that little guy right there. That's M50 or M81 and M82. Looks pretty good, I think. This was in equatorial mode. There's the Leo triplet. I did this from my house. In fact, that's the RGB data I used with the other luminance shot that I showed earlier. This one's a good one. I like this one. The Sunflower Galaxy. This was taken down at JGAP with the S50. S50, by the way, is great for galaxies. I don't use the S30 unless I want to do a grouping of galaxies, but the S50 is great. This is a cropped image. So if you look at it, think of it like a large area down here and a large area up there. And what I did is I cropped it. And I'm able to get this kind of resolution with the S50. I'm pretty impressed with that. And I did not know that there's that dark band in front of the Sunflower Galaxy. I was like, I didn't realize that was there. Here's M13. Yep, look at that little galaxy right there. All right, so that was with the S50. That's 40 minutes. Now, dark skies are wonderful for the SeeStars. You do a great job with it. I want to show you what some other CAS members are doing, and I want to kind of feature Tom. So Tom Roberts, I call it the SeeStar Brigade. He comes down with 3 SeeStars. Now, what can you do with 3 SeeStars? You get 3 times as much data. If you have 3 SeeStars and you're focused on one object, every hour you get 3 hours. This is the image he took that night I was down there with those 3 SeeStars. This is 12 hours of data on M81. For $1,500, he got that versus, I don't even want to say how much I spent on my rig. But that's pretty cool, especially if you don't want to spend all that money, but you want to get into astrophotography. Here's 2 hours of data on the Iris Nebula. And look at the detail he got out of the Crab Nebula, 8 hours worth of data. And he does most of his imaging from John Glenn Astronomy Park. So our very own Joanne Kahns, she has been having a ball. She has no interest in learning how to process or post-process her images. She's just tickled that she's able to go out there and just capture images. She has wanted to do this forever, but never wanted to sink all this money into it. That's one of the great things about smart telescopes. You don't have to spend a lot of money on it to get started. And any skill that you learn post-processing a smart telescope picture, you can use if you want to expand into the world of astrophotography more. I mean, if you learn PixInsight doing smart telescope stuff, you can do it with Hubble Space Telescope pictures, right? And there's another free app or free application called Cyril, kind of similar to PixInsight, but it doesn't have all the additional bells and whistles. But it's free, and a lot of people are having great success with it. So I mentioned the Celestron origin earlier, and my buddy Josh, this is the Eagle Nebula with the Celestron origin. 30-second subframes. It's a 6-inch telescope. He's got a lot of good data in there. One of the things about the origin, it's very expensive. It's like $3,700 or more. They are slower on getting firmware upgrades. It still does not do equatorial mode. So he went out and bought an equatorial wedge so that he knew that was coming. The other thing about the Celestron origin, it's modular, and it works with the camera at the secondary. So it's using, what do they call that? Hyperstar. So it's using a Hyperstar camera, so you can swap it out eventually for a new one. So the Celestron origin has become a very powerful yet expensive system. Okay, so what am I planning to do next in the next year of using a smart telescope? I want to start doing astrometry. Now, astrometry is the science of finding objects in the sky that are moving, like asteroids and satellites and other things, and get that information and find out or submit that information, and they can understand how that orbit works. So I had fun one day when I should be working. I went on to the Minor Planet Registry and started looking up names. I found out that my favorite rock group in the world, Rush, all 3 band members have asteroids named after them. So I have a new goal. I want to go find those asteroids and take pictures of them and do astrometry measurements on it for fun. By the way, was it last night? I had the SeeStars up, and I got a picture of Vesta because it's close to opposition right now. And so that was kind of cool. So I'm going to take some pictures over a couple nights and do an astrometry solution for it. I'm thinking about getting a Star Analyzer 100 and 3D printing an adapter for it. The problem is it's too far away from the camera, so the spectra will go the spectra will go away off of the chip. So what you have to do is you have to move the telescope over so you can capture the spectra, and there is a way to stitch spectra together. So I'm thinking about getting a better diffraction grading. I want to continue doing photometry. One of the things that Kai Jung talked to me about is he's like, try to defocus the stars for doing photometry, because my estimates are brighter than what everyone else is getting. He's like, try that. So last night I did some images of some variable stars. I'm going to try that out, see if it looks a little better. I'm also going to continue, and I'm going to write tutorials for a lot of things I talk about, because I've been really in this writing phase of my life, and I'm starting to write more articles and things like that. So keep an eye on my website, xray-echo.com. You guys are like, yeah, I'm not going there now. I'm going to be like writing a tutorial on how I do spectra. I want to write a tutorial how I do photometry. I want to write a tutorial on how I eventually learn astrometry, and anything else I can think of. Now, a lot of people, they're like, are you done doing visual observing? Absolutely not. It's just right now, this is the fun du jour for me. And I think it's great because I'm somewhat of a very bad astronomy evangelist, and I think smart telescopes are really cool to get more people involved, especially in the younger generation today. Every hobby, I'm sure you've heard of this, has what are called gatekeepers. Gatekeepers, and I apologize if you are one in this room, gatekeepers are the one that says, those are stupid. They'll never be as good as a full-fledged astronomy rig. They're right. However, a lot of people don't have the resources, time, all that kind of stuff to invest into something they don't know they're going to like. This allows them to learn or to understand what it takes. You can't just point and shoot up in the sky and get these wonderful pictures. It takes work, it takes practice, it takes understanding. This is a great way to do that without having to break the bank. So I am not a gatekeeper. I am one of those people that is like, I think this is one of the best things for amateur astronomy in a long time. I really believe that. There are so many people buying these now. People who, you guys all know Jim Schultz. He has a former colleague that used to work at a different CAS, Chemical Abstracts. He got one, and he's never been interested in the stars. But what he does now, he sets it up in the front yard. Him and his wife sit out at the pool, drink wine, and tell the SeeStar, wonder what that looks like. And it just goes there and starts taking pictures. And he thinks it's the greatest thing. How great is it that we have something like this to get people to start looking up? With that, thank you. Now, any questions? Huh? Oh, yeah. All right, everybody look at the ceiling. I had a teacher that used to do that when we'd watch a film strip or something. He goes, look at the ceiling, and all of us are like, huh? And he turns on the light. So, yeah, Wookie.
Can you get any lines for the heavier elements? Or is that?
I don't think the resolution is high enough. Yeah. To get the best spectra, you want to get a slit spectrometer. That allows you to get those finer lines and things like that. With these coarse gratings, even with the star analyzer, you don't get that fine resolution that you can with a slit. Now, they have amateur spectrometers that are slit-based, and you can build one for under $2,000. And there are amateur astronomers out there that are getting scientific quality spectra. There is a database that you can submit that kind of spectra. I don't know if it's the AAVSO, but that other organization, BASS, they accept spectra from amateurs.
So you didn't mention, but these actually come with a solar filter. So if you want to take images of the sun, right? I mean, basically just, photosphere, I think it's actually kind of neat that you can, not only use it at night and just basically have a good time.
Yep.
Just during the day, you can also use it.
Correct. Yeah, I didn't go into too much of that because I kind of covered that, last year. But one of the neat things, and I kick at myself for not doing that, there was a very large sunspot group that came around the limb. Yeah. And I've been wanting to, if I can get a SeeStar out and get pictures of it. You could actually do some really neat things with the SeeStar. You put the solar filter, and you're right, they do come with solar filters. Put the solar filter on there, and like one day, take a picture of the sun, next day, take a picture of the sun, next day, and keep doing that. Of course, if you get a string of clear days like that, then you must be in heaven. But you can make an animation of the rotation of these, and you can see the changes, because those sunspots change. So yeah, I really wish there was a way, you can't do this, but put a hydrogen alpha filter on the thing. That would be neat, but yeah.
They have the spectral sensitivity of the S50 and the S30. I mean, so what the camera is actually adding to.
Yeah, so you can get that information. Sony publishes, the quantum efficiency, right? They're actually pretty good. Now, my ASI 1600 is not very quantum efficient. The new versions are. It can pick up that information. You're not going to get spectra of dim stars with the SeeStar, okay? You're going to get spectra of brighter stars. Also, you can get spectra of like planetary nebula, especially the brighter ones that are a little more compact. It's sensitive enough to get that kind of information, but you're not going to get information from a 9th magnitude star. You can get photometry from a 9th magnitude star. All right, well, thank you very much, everyone. I appreciate you. Very cool here.
Oh, yeah, actually you forgot. There's a star party at JGAP, Ben just reminded me, on Memorial Day weekend. I'm setting aside some of the parking spaces. We won't have to get them as CAS members, but I'm holding back a few of the parking spaces so that we'll have extra room. And people can go to JGAP on the 24th, which is Saturday, and then the backup night will be the 25th. So if you want to go down, just observe. It will be a program night. However, we've got a great big field. CAS members can drive around to the right of the plaza. There's a road, kind of a gravel road, and then you can drive up and unload your stuff around the back right of the plaza, and then pick it up and go back, or drop it off and then go back and take your car to the parking area. You are not allowed to camp on the site. Apparently that would be competing with the actual formal campgrounds, and that's no good. But you can sleep in your car if you're tired.
Yeah.
So, for safety reasons, if you need to take a little nap in your car before you drive home at 4 o'clock in the morning so you don't crash your car on the side of the road, please do that. But you can't set up a tent. So, but other than that, you're welcome to come.
So any questions before we close out for the evening? We're still working on trying to put together more observing opportunities for the club. Anyway, we're working on a couple of locations that we've used in the past. There's a place called Greaser Field, which is out west.
Oh, we can still get in there?
Well, we're working on that right now. We're getting a new permit for the state of Ohio because AEP sold it to the state of Ohio, and now the bureaucracy is, making it hard to do a simple thing like get permission to go out there and observe. So,
Yeah, and it's east, south of Zanesville.
yeah.
It's dark.
Yeah, it's near dark.
And primitive.
I'm pretty.
And for the Delta.
Yeah.
Yeah, it's got woods.
And did they bring the porta potty back?
Yeah.
Hug out, boy.
Good.
I don't want to hear
You can bring it on.
Is that a state park?
It's not, it's run by the
Or DNR.
service, but it's not a park
It's in the middle of
per se.
nowhere.
It's,
I know the permit officer.
yeah, we've got somebody working on that right now. But we'll call you if we.
But any help will be
Appreciated. Right.
I actually live in Collinsville. I'm about 5-10 minutes away from Regional Field.
Oh.
I was there yesterday night, got some pictures of it too. So they've actually been mowing the field.
Oh, okay,
And
because
stuff like that.
they said they were going to,
Yeah, they're still taking care of it.
So it's mowed?
It is, the field is, but the road leading up to it, they haven't mowed yet, but it is very wet.
Okay.
So I don't know if they didn't mow it because of the wetness or whatever. But I work for the Ward County Commissioner's Office as well, I'm their IT director. I can actually work with ODNR as well, if you guys give me some names or whatever. To talk with as well.
Okay. So any telescope questions or whatever?
Oh, by the way, at 9:34 tonight, there's a really good pass to the International Space Station. At JGAP, actually, it's going to be 88 degrees up, and here it'll be about 60 degrees up. So it's a very nice. It broaches the horizon at around 9:33. Should be up above the trees around 9:35, and then we'll be able to see it go pretty high across the sky.
That's different between here
It is clear.
Yeah, well.
Yeah, it's different. It's a 60 mile.
200 and some miles up, so.
Yeah, it's 66 miles or something like that, and it's 240 miles up, so then it's, from here to here, so.
We can try and make it to JGAP.
I'm sorry?
Try and make it to JGAP.
Yeah, I'll try. I try really fast.
We saw it nice in Delaware last night. We worked at a public event there up at Ohio Westland. It was kind of nice, and you just spotted it come over. Of course, you see all the Skylink satellites sort of drifting.
with the trains.
Yeah.
As you know, we came within one orbit of having the Russian Venera crash in Ohio.
Oh,
Because the next orbit was right over in Central.
so where did it end up at?
The Indian Ocean. Indian Ocean.
Oh, well.
Hey, but it was a big ball of titanium. I mean,
Yeah, you didn't want it falling in your yard.
Actually, I think I would have wanted it to find it.
Yeah, make sure your homeowner's insurance covers the flying objects.
Yeah.
I'm sure that.
Although, I think the selling it to a museum would pay for the damage.
So one of the things about the space station for ham radio operators, I want to see if I can monitor it from my car. You can actually hear the packets from the space station.
You just need a little antenna, right? Just a
Yeah. I've actually connected to it. So, but anyway, we'll see if
For a few minutes,
right? Cool. Yeah.
So, I guess that's it. If anybody's setting up scopes or whatever, we'll do a little viewing.
Can anybody bring any telescopes?